Okay, this is problem RREF, reduced row echelon form, question C10, and here's the system that we would like to row reduce. So what we're going to do is try and identify the solution to this system by using row reduced echelon form. That first involves converting this into an augmented matrix, and of course the augmented matrix is the matrix of the coefficients welded to the matrix of the solutions, or the vector of the solutions. So it's going to look like this: 2, -3, 1, 7, 14, 2, 8, -4, 5, -1, 1, 3, -3, 0, and 4, and -5, 2, 3, 4, and -19. Okay. Now, going through the operation of row reducing is pretty tedious. It involves using this system and then deliberately choosing particular equations to represent equation 1. I would choose this equation right here to represent equation 1 because it already has a pivot with a 1 in its first location. Then what I would do is use combinations and sums of the equations to reduce all of the other equations to having a 0 coefficient. Because I have a 1 here, I could multiply it by -2 and add it to this one, -2 and add it to this one, negative or +5 and add it to this one, and then I could get all of the other equations to have 0 coefficients. Of course, it would influence the rest of their variables as well, but then I would get 1 with all zeros. And then I would work my way down the line. I would do the same thing in the next one. I would choose one of the other equations to have a 1 in this column, and I would make all the remaining equations 0 by utilizing that particular 1. Because they'd already have zeros here, their multiplications and sums wouldn't alter the initial column. Once I do that all the way down the line, I'll get as many columns as I can with just a singleton 1 and zeros in the remaining. It will be impossible for some equations to produce this, but it's generally possible for it to get a couple of solo 1s in columns. What we can hopefully do is convert as many as possible, and then we can get the solution to the system by having that reduced row echelon form of the matrix. Because of how mathematically tedious it is, especially for a 4x5 matrix, we're going to tend to use digital solutions. So in class, I'll show you how you can get your calculator to give you a reduced row echelon form of a matrix. And of course, the textbook provides you with a saved cell that will do it if you just enter the matrix in. I've run that for this particular matrix, so the RREF ends up looking like this: 1, 0, 0, 0, 1. Next line is 0, 1, 0, 0, -3. Line 3 is 0, 0, 1, 0, -4. And the final line is 0, 0, 0, 1, 1. So this particular matrix cleaned up really nicely, where we ended up with 4 pivot points, which means we can solve the system exactly and get one solution. In essence, the first equation becomes x1 equals 1. So that tells me that x1 is 1. The second line tells me that x2 is equal to -3. The third line tells me that x3 is equal to -4. And the fourth line tells me that x4 is equal to 1. Therefore, this system has but a single solution because the reduced row echelon form worked perfectly and ended up giving me the solution to all 4 variables. There's sort of some indicative numbers that we can talk about here. The number of pivot points R is equal to 4 in this case. And of course, because the number of equations or the number of variables is also 4, that means we can find one solution here. And we didn't end up with the disaster where we had a pivot row as our solution vector. If there's ever a pivot here where this is a 1 and everything else in that row is a 0, that can be problematic because no combination of variables can produce the one, and that disaster means there's no solution to the system. But that didn't happen here.